All right, the number of milligrams D of H of a certain drug that is in a patient's bloodstream after H hours is injected by the following formula. Write the number of milligrams when it reaches 17. Okay, so this is reaches 17, and that is when it's D of H. So that is my D of H. So I do 17 equals 45 E to the negative 0.25 H. And then I divide both sides by 45. So 17 divided by 45. I'm going to leave that as a decimal for just a sec, or a fraction. And then I have E to the negative 0.025 H. So I need to get that down. The way I get this down is I do the ln of both sides, and that drops it down in front, but I have to do the ln of both sides. So now I have the ln of 17 over 45 equals negative 0.25 H times the ln of E. All these problems follow the same exact problem. That's why I was trying to do that on the first one. What is the ln of E? Ln of E always equals 1. So really that just kind of goes away. And you can divide by the negative 0.25 and get your answer. So the ln of 17 divided by 45 divided by 0.25 negative would be 3.89. And that should be my answer. Let's go hope and make sure I did this one right. Oh, I clicked try another. I'm pretty sure it was right. This one would be, I'll check this one to make sure I did it right with divided by negative 0.038. Okay, we did it right. All right, next one is finding the final amount. When you're talking about finance, all of these, like I said, are going to have the same problem. This is a formula that pops up on here. We'll see if it's on the test in a minute. But this one is A equals P times E to the RT. We talked about E already. This is the same E. They call that Euler's numbers. 2.72 is the way you round it. P is your principal. A is your, this is your starting amount. And this is your final amount. R is your rate, which you always write that in a decimal. Like we're talking finance here. And T is our time, okay? We know to use this formula because it says compounded continuously. So you might have seen this formula somewhere, but I'll give it to you on the test or whatever if we need it, but I don't think you do. So initial amount is 1,500, a rate of 9% per year. Compounded continuously tells us to use this formula. Find how much is in the account after 5 years. So we're just trying to find the ending amount. So this one we're just going to plug in 1,500 times E to the RT. Okay. Does my phone does have the E button. So E to the R is 0.09 and T is 5. So this should be about 230, 52, 47. Okay, so that one's pretty easy because you're just plugging it in. The last one here, you do have to find the initial amount, so it's the same formula, but it does make it a little harder. All right, so still using that same formula. Again, you know you're using this formula as soon as you see compounded continuously. So my A is Mr. and Mrs. Jones hope to send their daughter to college in 14 years. That's my time. How much money should they invest now with an interest rate of 9.5%? So that would be, what, 0.095. Compounded continuously tells us to use that formula in order to contribute $80,000 to our education. So that's how much money we want in the end. We are trying to figure out how much they should do now. How much should they invest now? That tells us we are finding P, okay? So we do 8,000 equals P, E to the RT. R is 0.095 and T is 14, okay? So to get P by itself, what we'd actually do is divide by e to the 0.095 times 14. You could go ahead and multiply those out, but I'm going to wait just so I can do it all in the calculator at once. So if I divide both sides by that, I get 8,000 divided by e to the 0.095 t equals P. Okay, so I do 8,000 divided by e, e to the 0.095 times 14. Very easy to do in the Alex calculator because it's just easier to see. So they would need to invest about 211582 right now, and then it would turn into 8,000 in 14 years. All right. Just for my video purposes, I'm gonna go back and like do that problem, the first one more time. I'm sorry. You'll have to deal with it, but that's fine. So let's try this one more time and make sure I put it in the calculator correctly. And we can do it the way that they do it, but I do think it's helpful to know how to do that in the calculator. So if it loses 20% of the value, that means it's keeping 80% of its value. So you do 0.80 to the first power would be like it loses 80% the first year. 0.80 the second value, so 0.80, or it's keeping 80% for the first year. So 80% squared. Now it would be worth 64%. 0.80 cubed, 0.8 to the third power. Now it's worth 51%. So it doesn't lose 80% or 20% every year. It's losing 20% of the value of its cost that year. Okay. So if I did 31,000 times 0.80 to the t, because we're trying to figure out how many years. And we want to know when it's going to be less than or equal to 14,500. To get the t by itself, we could divide by 31,000. So 15,400 divided by 31,000 is 0.80t. When is this less than 0.49677? What they do at this point in time on Alex is just go check it, right? Because the third year is 51. So if I did 0.8 to the fourth year, so if I did 0.80 to the fourth year, it'd be 0.4096. And that would mean this number is lessened. So my answer should be 4, since 4096 is less than this number right here. If you were to solve this algebraically, just to show you, it's the same thing that we've been doing. I do the ln of both sides. The t drops down out in front. So I have t times the ln of 0.80 is less than the ln of 0.49677. And then get the t completely by itself. I'm going to divide by the ln of 0.80. And I get t is less than or equal to, what was it, 4,000 divided by 31,000. Kind of just doing it all, divided by ln of 0.80. T is 3.135, okay? This is saying that it will, this says it will go below 15,400 in the fourth year, right? Because that would be 3 years plus 3 years plus 0.135 years. So in the fourth year somewhere, 0.13 of a year would be like, 60 days or 14 days or something. I don't know.